You spent weeks preparing. You sit alone in a dark room, staring into a brightly lit webcam as a timer ticks down. You know your skills are a match, but the rejection email arrives anyway. Top-tier engineers and data scientists are failing automated screening interviews at an increasing rate. These failures aren't the result of a lack of technical ability. They stem from a basic misunderstanding of the format. Candidates naturally attempt to have a normal, conversational dialogue. They are feeding unstructured, rambling human speech into a system built to process rigid data. Platforms like MicroOne use AI recruiters like Zara to conduct these screenings. Zara does not evaluate your personality or interpret emotional context. She is a data parser, and she cannot make the implicit logical leaps a human interviewer would. Every word you speak is immediately processed through an NLP pipeline, a multi-stage algorithmic filter. This pipeline consists of 4 distinct stages: input capture, NLP transcription, logic mapping, and formatting. Your spoken words are immediately converted into raw data blocks. To generate a passing score, these blocks must successfully pass through each node without being discarded. To pass an algorithmic interview, you have to stop treating the webcam as a conversational partner. You must start structuring your speech as a precise database query. The process begins at the first node, the physical hardware capture phase. The primary technology governing this phase is voice activity detection, or VAD. VAD relies entirely on a continuous audio stream. Unlike a human, the system cannot see you pausing to think or doing mental math. It only hears the silence. This creates a silence trap. A brief pause to structure a complex thought triggers the system to assume your answer is complete. The algorithm abruptly cuts you off and permanently lobs whatever you said up to that point as your final, potentially incomplete answer. You prevent this by using a behavioral countermeasure called speak to pause. You must verbally declare your state tracking. Instead of thinking in silence, you say, "I am evaluating the constraints of this problem," or "give me a moment to structure my approach." This continuous verbal output keeps the microphone channel open and explicitly feeds your intent to the system. If you catch a mistake and course correct out loud, the algorithm logs this as a positive signal of internal validation. It shows you are actively checking your own logic. Proactively managing the audio threshold is the only way to prevent the algorithm from terminating a technically correct response before you finish delivering it. Once the audio is captured, it moves to the second node, NLP transcription. The AI now calculates your semantic density, the ratio of hard data points against your total word count. The algorithm categorizes emotional context, vague buzzwords, and conversational filler as noise. The system acts like a sieve, searching for a specific signal, explicit technical nouns paired with strong action verbs. The density of these high-value words determines your baseline competence score. A phrase like, "I'm a hard worker who knows Excel," is low density. An answer stating, "I utilized VLOOKUP functions to automate inventory reconciliation," provides the specific data points the AI requires. The NLP model cannot infer implicit skills. It only knows what you explicitly state. If a specific tool, software, or metric isn't spoken, it does not exist in your evaluation profile. Optimizing your semantic density ensures the AI extracts your technical expertise, instead of discarding your answer as conversational noise. The third node is logic mapping, evaluated via chain of thought processing. The algorithm tries to draw a continuous path from the initial problem to your final solution. This requires syntactical joints, structural words like because, therefore, assuming, and however. These words act as code that binds variables together in memory, transforming isolated facts into a sequential graph. Omitting a syntactical joint creates a logic gap. Even if your answer is correct, the broken connection causes the AI to fail the response. This is critical in complex scenarios, such as calculating the probability of getting exactly 50 heads in 100 coin tosses. A common mistake is attempting to calculate a massive number like 100 factorial in your head. Calculating that number naively in a computer program causes an integer overflow error. The number is too large for stiff joints to explain why the textbook formula is dangerous in production. You then use those same joints to justify switching to a normal approximation model as a safer mathematical choice. The AI is not grading the final arithmetic, it is grading the explicit state tracking and the logical justification of your methodology. Using these joints proves to the algorithm that your answer is the result of a repeatable engineering process, not a guess. The data finally reaches the output formatting node. Most people view the STAR method, situation, task, action, result, as generic storytelling advice. In an AI interview, STAR is a rigid data formatting protocol. Chronological speech allows your words to slot perfectly into the machine's expected variables. Stating the situation and task establishes the problem constraints and target goals in the system's memory. Action and result provide the execution and measurable outcome needed to close the logic loop. Delivering unstructured speech to an AI is the equivalent of submitting code with syntax errors. The STAR protocol is what allows the answer to compile. To pass, you must clear 4 hurdles: manage voice activity, maximize semantic density, provide chain-of-thought logic, and use STAR formatting. Navigating this pipeline requires a shift in how you process information. The effort of stripping away vague filler and explicitly defining logic gaps results in an immediate organization of internal thought. This discipline results in a degree of structural clarity that human technical teams rely on for complex collaboration. By learning to satisfy the algorithm's requirement for structured reasoning, you have developed the precise communication skills needed to lead